basically, we've got just a very general overview of the FAIR principles. FAIR principles are a set of concepts that ensure that data are shared in a way that enables and enhances reuse, so by both humans and machines. These principles emerged from a workshop held in Leiden, and that was in like 2016. Oh, I probably shouldn't have made that up, but yes, I was right. And I don't know about you, but I really wish I would have been a fly on the wall for some of it, but some of that workshop, but maybe not when they were trying to put the acronym together, because I feel like that has to always be painstaking. But this led to an article in Nature by Wilkinson et al. And the focus of that article was really on these sort of broad principles. And the focus of those principles is on data and metadata. These principles have become really far-reaching and have become more applied practice and by way of the 3-point verification framework. So this framework provides a sort of a practical how-to guide to FAIR data. And so we'll be using this framework to guide our presentation today. So, but FAIR is essentially making data findable using a persistent ID, descriptive good metadata, to be accessible using standard protocols and open metadata, to be interoperable with references to other metadata and standard metadata and FAIR vocabularies, and reusable. So making sure that there's a good provenance and clear data licensing. So that is sort of the 2-cent tour of FAIR principles, and we will be diving more deeply into those as we go along. And I'd like to hand it over to Nathaniel, who will get us started on the first part of FAIR.
All right.
I'll stop sharing.
Thank you so much. And let me share my screen, just a minute. Okay. All right. Okay, can everyone see my screen?
Yes.
All right, excellent. So, hello everyone, welcome. And my name is Nathaniel Didibanfu, the GIS Services Specialist at Texas State University. I'm really excited about this. We're going to talk about metadata and then the FAIR principles behind it. So before we dive deep into all the different principles of the FAIR idea, we want to understand what metadata is. Just for
Nathaniel, I'm sorry to interrupt, but we do see your screen. We just don't see the slides.
Oh.
I see a lovely photo.
Oh, really? Okay. What is going on? All right, let me just share it again. Okay.
A lovely desktop.
All right. How about now?
Yes.
Perfect. Okay.
Got it.
Thank you for pointing that out. All right. So we are going to take a look at what metadata is. So metadata is simply information or descriptive information about our data, sometimes simply described as data about data. So that is what metadata is. And it contains very important information which every data user must actually know before they start using. And the third point is, ideally, it has to accompany every data set that you download. And as we know, your data is as useful as the metadata that comes with it, because without the metadata, there are some limitations to every data set. As you probably know, there is no data set that is 100% accurate or certain. There is some amount of uncertainty that accompanies every GIS data. So the metadata provides some form of basic information, crucial information to alert the data user before they start using it. So that is the reason why I state that your data is as important as the metadata that comes with it. And metadata has been given, the federal government assent by virtue of an executive order passed, issued by President Bill Clinton way back in '94, that made it mandatory for all federal agencies to produce a metadata to accompany their GIS data. So if you're working with a federal agency, then if you're going to produce a GIS data, it has to be accompanied by metadata. All right. So having said that, let's take a look at why metadata. I have already alluded to some. It eases GIS data creation. What do I mean by that? When the metadata is available, it provides some information to a new user. Let's say they want to replicate that. The metadata provides that kind of background information to enable them to replicate or to do the same kind of process to produce the same data set. So metadata is very helpful in that instance. It also provides quality assurance. So even though we know every GIS data has some level of uncertainty, but the metadata that accompanies it provides that assurance to the user. At least if I know that this data set has these limitations, I will be guarded when I am producing or running with it. If you just assume that this is good and then you just run with it, then of course, as we know in GIS, error propagates error. So if you know all the limitations, it provides you that kind of assurance that, okay, at least I know these are the issues. So this is how I'll approach it. Issues like ecological fallacy and all that. Another aspect is to encourage information distribution. If I have the metadata, I have the confidence to share with others without looking back and say, oh, what are they going to do? What if they encounter these problems? Or even if there are some problems, the metadata will provide some aspect of information like, okay, in case you hit this snag, this is what you can do. You can contact the original producer or the author of this data, and here are some of the things you have to know. And let's say in your metadata, you have things like abbreviations. As we know, a lot of time when we are producing attribute data, we abbreviate a whole lot of things. Metadata can provide some information regarding that. So it encourages information distribution. Then finally, it provides some economic benefit. So thus we realize it through, metadata will prevent wasteful duplication. So if I read the metadata that accompanies an existing data set, I can know, oh, this is talking about this, even though the abbreviations and attributes are using different titles, it's the same thing I'm looking for. And therefore, I don't have to duplicate it. And this is very crucial, especially if we're working for the government. We are using taxpayers' dollars. So if there is a wastage of funds for duplicating all kinds of data set, it's not a good, we are not being good stewards of the society's money. So it actually prevents that. And then promoting effective and economical management of resources by federal or different levels of government. So these are the reasons why metadata is really important. So now we're going to talk about the FAIR principles. And I have the privilege to talk about F, findable. So before I go into it, most of us are used to metadata that accompanies, sometimes accompanies our GIS data. They usually come in the form of an XML file. So if you have a shape file, the shapefile has the SHP, the DBF, the SHX, and what have you. and also the XML file. The XML file usually will contain the metadata, but what we are focusing here is how do we make our data set more findable, accessible, interoperable, and then reusable. How do we make it? Because if you have the XML file, it's just sitting on your computer, or maybe it's just sitting on a server somewhere. But the goal here is to make it more available worldwide. So the first thing is findable. And there are 4 principles under findable. The first one is, in order to ensure that our data is fair, okay, findable, and then the rest, we have to assign a globally unique and persistent identifier. We'll go into details about that. The second is to enriching our metadata as much as possible. The third is we have to clearly and explicitly include the metadata, the identifier to the data or the data set inside our metadata. And then lastly, having done all these things, we have to make sure that our metadata is searchable, easily findable by popular, search engines like Google and stuff. Because it's not enough making all these things and still your data sits somewhere relaxing. So let's take a look at all of them one at a time. What do I mean by a globally unique and persistent identifier? Okay, when it comes to this is a specific code or ID we assign to our metadata or the data sets that we are producing. Why the need for this? As we know, when we develop our websites, a lot of cases, we have issues with broken links and things like that. Let's say we're refreshing our web page, and then there are certain links that no longer can connect to the server. When that happens, it means we have to hire somebody or we have to assign somebody to go and find all these things. So to prevent all that, so that our data sets will not be lost in the middle of all these problems, we can assign a unique or and a persistent ID. And once we assign this, no matter what happens to the website, this will remain. Anytime anyone clicks on it, it's still going to refer to that location. So that's why it is important we assign this unique and persistent ID. It's global because wherever you are, it doesn't matter the language you're using, it doesn't matter what platform, it's still going to go straight to the data set. And it will help us locate your data set. It will help us because as research universities, we need to provide access to these data sets so that the public can benefit from them. Okay, so here are just examples. Okay, so once you click on this, no matter what, it's still going to go straight to that data set or whatever you want people to find. So some suppliers of, globally unique and persistent IDs. These are some few examples. So identifiers.org, they provide a platform to generate these codes. And there's also persistent URLs, okay? So you can visit these websites to help generate your unique IDs. All right, so next we have to enrichen our metadata. If we want it to be more findable, okay, we have to provide as much information as possible in the data, the information that accompanies our data set. So some of the crucial things we can include is what is the source of the data, okay? Where is it coming from? Is it coming from Texas State? Is it coming from Texas A&M? Who is the author? Who produced it? The professor who produced it or the student who produced it. The coverage area. These are some information you can share. Okay, does it cover entire USA? What is the name of the study area? Is it just San Marcos or Austin? What are some of the content information regarding the spatial? For example, the model and the structure. Is it just a shape file, or it's an maybe it's a KML file? What is the spatial reference? Like information regarding what we call projection, okay? And then attributes. So if you're using acronyms in your attribute information, you can provide some information here. Procurement time, when was it captured? Okay, this is very useful, especially when it comes to raster data set, like satellite imagery and stuff like that. They are very, very important. When it was captured, you have to include that. Creation process, you could provide a brief description of what went through. Okay, I did this, these were some of the assumptions. And then data quality and limitations. Okay, what are some of the limitations? For example, if I download a road layer, can I use my road layer to run things like geocoding? Can I do a desktop geocoding, use the road layer? Okay, some road layers, no, a lot of them you can't. It's just for display purposes, but you can include that in the metadata to provide that assurance and guidance to the user. And then things like cost and licensing. So the more information you provide, the better. And we'll see why shortly. And then the final 2 points, once you produce it, I will also encourage that, or the principles encourages, the principles encourage that you have to include the identifier, which we saw in the first principle. You have to include the identifier in the metadata so that when people open the metadata, they can still locate where the data set itself reside, okay? And then finally, data and metadata um, must be registered or indexed in a searchable resource. What do I mean by that? You don't have to literally go and pay for something, but the information that you provide in principle 2, that is enriching it, and then the persistent ID will help you so that search engines can easily find them. So Google uses a process of crawling. Okay, once you hit some information like a keyword, Google will crawl over the internet and then try to locate all the places or the servers that will provide that. So the more information you have in your metadata, like once you have enriched it, it will help Google to easily locate it. Okay, and you don't have to put it on a very obscured location. It has to be in a popular repository. And fortunately, we have the Dataverse here in Texas. So big repositories will easily help people find your data set. And if you're using your own server, be mindful of firewalls or private pages, because these things can limit search engines from finding your data. And finally, you have to provide phrases. Ideally, if you provide like 3 or more phrases, word phrases, it helps Google and those search engines to easily locate your data sets and the metadata. Because if you provide just a keyword like GIS, in general, it faces a lot of competition in the search engine world. So it's going to produce a whole bunch of pages, but if you increase the phrases, it helps limit it and then easily find that. So that is the reason why you have to enrich in your metadata so that whatever phrase people type, they can easily locate your metadata. And John, how are we doing on time?
Doing good.
Okay, I just want to quickly just show you an example. So this is Dataverse, okay? And you can see all the universities that participate in it. I'm going to be biased here. I will jump straight to Texas State. Okay, so on Texas State, this is the page. People have shared a whole lot of data sets here. So I am on Texas State repository, and I'm just going to be a little bit, let me type this phrase, okay, GIS, and then there's a professor I know, his name is Currit. Okay, so this is a phrase I'm typing to search for that, and then I hit enter. I hope the internet will cooperate over here. Initially, it was slowing me down, so hopefully, let's do it again. GIS Currit, okay. All right. And I found this professor's data set. So it's detecting impervious cover with artificial lighting in astronaut photography from the International Space Station. That's pretty advanced. Let's see what we have over there. So I click on that and it takes me here. First, right there, we can see the unique identifier of the data set, okay? But I want us to go into the metadata. So this is the data, okay? And right here, I can see he just uploaded, the geodatabase because it's coming with these formats. So a geodatabase was uploaded. And if you go into the metadata contains the persistent ID that will lead you to the data set itself. So one check mark over here, this person did the right thing. Publication date, this is when they published the data. Okay, the title is there. Who the authors, okay, the first author is Johnson Bradley. And then like if you want the contact, you can get over here a little bit of description, what is the subject, okay, and all that. So this helps a lot instead of just relying on an XML file that is attached to your shapefile. Once you have this, it helps your metadata and the data sets to easily be findable. Okay, people can easily find it on the internet. And with that, I'm just going to stop and hand over to John. All right, take over, John.
I think you have one more slide.
Oh, yeah. Okay. Okay. Yeah. All right. Let's wrap it up here. So the final thing is having understood all these, what are the best practices we have to adopt? Whenever, if we are looking for our own GIS data, we always have to pay attention to the metadata. We have to seek for the metadata. If you just download it, you're going to face problems. So always seek for metadata. The second point is when you create your own data, let's say you digitize or you did a research and you got some data, make sure you generate a metadata right away, okay? Make sure. And once you share it into the cloud, make sure that you provide all those information as well, just like I showed you in the Dataverse. And when you share your data with people, or when you share it on the cloud, remember to share the metadata as well. Fortunately, most of those platforms will force you to provide a metadata. If you don't provide it, you will not be able to upload your metadata sets. Okay, and I think that does it, right?
That's it. Yep.
All right, good.
All right.
So let me stop sharing and you carry on.
Okay. All righty. So moving on to accessible here. This is these are some of the verification practices that data and metadata are retrievable using standardized communication protocol. and that protocol is open, free, and university implementable. The protocol allows for an authentication or an authorization procedure where necessary, so a login, and metadata are accessible even when the data are no longer available. So I like that one, that's a little tricky one that they threw in there at the end. So let's just talk about some examples about these. So for accessible data, it's often, again, sort of addressing that platform where data are archived. And here's an example of data stored on a server. This is from the Brazos County Appraisal District. So they share monthly data that on their website. So here it is accessible through a simple web protocol for download. So they're following part of that FAIR principle for accessibility. However, the missing piece here is this sort of human and machine readable metadata. So they don't supply metadata along with the data. So you're getting kind of half of that FAIR principle. However, going kind of back to the Texas data repository, here we have a similar record, and you can improve that the accessibility of these different files is by being able to export metadata. So having that protocol not only to download data or to make it accessible using a web protocol, but also the metadata. So it's not just the data that's able to come with you, but also the metadata. The platform should also provide an option for displaying metadata even after the data have been removed. So we probably heard a lot about link rot. If you have any kind of experience trying to find something that was written a long time ago, and that is a very real thing. It's actually a real big problem in citations. And so, finding this 404 is really kind of detrimental to someone who's trying to use the data. But it is fair to say that your data may need to be deaccessioned. It may need to go away because something was either wrong or it just had deprecated the file format, one or the other. However, if it is cited somewhere, there should be some sort of tombstone page. So that's what we see here on the right as this example of a tombstone page. So this is something that that is a capability in the Dataverse collection, the Texas data repository. Is anyone with a persistent ID from that data will be able to see information about the deaccession data set. This was the best example I could find of this. It doesn't have a lot of metadata, but at least it has some and an owner contact information. But typically you would leave the entire record up, even though the data are no longer available. So that would be following a best FAIR principle for accessibility. And I think this is just sort of our opportunity to throw in this because I feel like I have these conversations a lot, and I'm wondering if other folks in the room do or are using GitHub. And it's become such a standard archive for software and data. However, these repositories it's more of a social network repository, and they change frequently over time with varying forks and just changes from multiple members of a team. It's sort of a living, breathing data set archive. And so, and what I think people are so accustomed to doing is saying that data are available. We use GitHub. And so I think there's a lot of really great questions one could ask to follow up about that to make sure that it's accessible and findable. Is to sort of look at, is there a DOI associated with the data or code? And GitHub actually does do minting of DOIs through Zenodo, which is a data repository. So you can actually link your data from your archive in GitHub to Zenodo archive, and then that will mint the DOI for you. However, it's not, it's then transferred over to another place, and you can't make updates to that, but it is sort of a different concept than just leaving it in GitHub, you're at least now putting it in this repository where is there metadata associated with it. So if it is in a Zenodo repository, or if it's in something like the Texas data repository, as Nathaniel said, they would have to be. And do the DOI metadata reflect, and the data reflect the research at a time of publication. So often researchers will want to archive their data in a repository and share that DOI with the paper, the sort of coinciding paper with the data. And so what I think the best thing about repository is that it takes that snapshot of the data at the time of that publication. So this was the data from that publication. It can live on in GitHub later, but at least you have this other copy in a repository that really has sort of frozen in time in relation to the findings of that paper. So that's kind of the difference I see, and others kind of see with sort of the GitHub fan page is it's great, but it's not always going to give you everything you need to make your data fair all the time. And I think it also just basically serves a different purpose. That's sort of a living, breathing archive on a social network, or the snapshot of your data. So accessible also means, in the context of GIS, is these file formats. So these formats for geospatial data can be really tricky, and often they can create barriers to other people accessing them. So choosing open standards for file formats can help to alleviate cross-platform issues. So Esri, sort of the standard, only works on PCs and is prohibitively expensive. Obsolescence can be rapid with Esri formats, especially with complex functionality. So for example, like geodatabase with rasters is unreadable by anything but Esri software, which is, again, that proprietary, sometimes prohibitively expensive software. Formats like shapefiles, files can be sort of unwieldy, multiple packages of files, and they can be unwieldy for accessing. Their truncated field headers. Tables need XY coordinates explicitly, and the format is mostly open, so it's readable and writable by most GIS software, such as QGIS, but not fully open specification because the file format is created and controlled by Esri. So they are the standard, shapefiles are the standard, but they are not necessarily an open specification. So I'd like to take a few minutes here just to take a break and see if there are any questions. But what we've discussed thus far, feel free to unmute, feel free to put it in the chat. Okay, I don't see anything, I don't hear anything. So we'll just keep moving forward, and we'll have time at the end too for questions as well. So, all right. So we're gonna move on to interoperable. So that is to say that data and metadata use formal, accessible, shared, and broadly applicable language. Data and metadata use vocabularies that also follow FAIR principles. So those are vocabularies that are open and they're findable, accessible, interoperable, and reusable. And the data and metadata include qualified references to other metadata. So we can't necessarily go through each one of these, and again, we're trying to sort of give you a little bit of a taste of everything, but I'll talk a little bit about these. So both data and metadata, to look at sort of a well-defined framework is to describe the structured metadata. So commonly using controlled vocabularies or ontologies, and having sort of a resolvable, globally unique, and persistent identifiers as well. So data and metadata use controlled vocabularies that are also FAIR So it's sort of the idea of just making sure that those vocabularies are accessible to everyone as well, and not just something that is used within certain circles. Data and metadata should include qualified references, should be sort of building as many unique links between resources as possible while balancing sort of that time and energy. So connecting your data to the resulting paper, connecting it to other images that you may have, other materials used in that research process. So I also just wanted to kind of take one little breather here and just talk about machine readable. Sometimes I always feel like we talk about machine readable without really always explaining what it is. And these are some of different definitions. The term machine readable, when used with respect to data, means data in a format that can be easily processed by a computer without human intervention, while ensuring no semantic meaning is lost. Or in a kind of, I think, simplified version, is any structured text or data that you can copy and paste and can be accessed using a network URI. So using some sort of network computer where you don't actually, I should be on a system that is findable by a network. It should be, and I should be able to use a web protocol and not have to download it first. So we'll show some examples of those. So we humans kind of need to understand whether the data will be interoperable with other data, but our machines also need to be able to read them. And this isn't possible if GIS data are zipped up, like this example from the TDR. It should also contain enough information and ideally a way to preview content prior to download to facilitate potential reuse without access to specific proprietary software. So those metadata need to be described, not just the contents of the file, but also the technical specifications of the systems required to read them. And metadata need to be interoperable too. So thinking about the importance of referring to controlled vocabularies, using standards like ISO 19139, the Open Geo Consortium, Geo Blacklight, something that is a standard metadata schema. And so this is just kind of one example of, this is what Jessica brilliantly calls sort of the black box of the zip file. It's not really knowing what's in there and having to kind of download it and parse through it in order to understand if it's something that your machine can use. So on the flip side of this, the Advanced Computing Center plans to run this open source GeoServer platform, which will allow users to share and access geospatial data as open Geospatial Consortium web services. So these services enable users to directly access shared geospatial data layers using a variety of software and web applications as clients without needing to download data files to make complex and often proprietary geospatial data formats widely accessible to other tools. So these client tools can include so ArcGIS or QGIS, both online and desktop. So this OGC services also allows data publishers to have fine-grained control over the display characteristics. So what's previewed here, and the manner in which data are shared. So sort of this control over layer level display. So if you're an author, you can kind of decide what it is that you'd like to have displayed here on this preview. And then on the right, you have sort of the land parcels 2019. This gives you the actual URL to preview the map. And then copy it over to your machine or whatever tool you're using. Sort of those are the two not so fair and then more fair here. So we also have kind of moving on to reusable is to think about how metadata and data should be well described so that they can be replicated or combined in different settings. So the data and metadata are richly described with a plurality of accurate and relevant attributes. So kind of this is a lot about what Nathaniel was talking about earlier. But we can also talk a little bit more about data and metadata are released with a clear and accessible data usage license. And data and metadata are associated with detailed provenance, and data and metadata meet domain relevant community standards. Okay, so I wanted to kind of take some time to think about this licensing piece and how often I'll describe this to researchers who are looking to license their work. And I think about it in sort of these three areas. So what the license works with. So the domain of application, or what type of materials this license should and can be applied to. And then the term by in the license. So CC by means often that this requires attribution. So it means that it's a citation. You have to give credit where credit is due. Or SA, which is just sort of, we're sharing this, but we ask that you share alike. So license this work under the same terms, but, so those can be kind of interchanged. These three kind of areas tend to sort of be a way to break down that kind of licensing maze that we often have to go through in describing this with different researchers. So just thinking about making sure that we use something like Creative Commons CC 0, which is sort of that base level. This is something that if you're working in the Texas Data Repository and you're publishing your data there, that's the default. Any content or data can use that. So by content, I mean articles, images, your own work, your website, your libguides. And then this is sort of all rights waived. So no attribution necessary. The Open Data Commons public domain dedication and license is dedicated to that public domain as well, all rights waived. So that's sort of this data specific CC0 option. Creative Commons Attribution 4.0 is that CC by, and that is basically saying we want attribution, but do what you want. You don't have to share alike. You can kind of do whatever you'd like with this. Even make it commercial if you'd like to. And then this Open Data Commons Attributions license is asking for that attribution as well for the data or databases, and not really concerned with how others share that work moving forward. And then the Creative Commons Attribution Share Alike is the sort of connector to that. It's very similar attribution, but this one's asking for that attribution and then use that same license with your work. So also make it share alike, which means that then you kind of make it sort of proprietary after that. The MIT license is more popular with software, but is more common, especially in the GitHub community. So that CC by, or sorry, MIT license it doesn't necessarily require any attribution, but it does ask that it be shared. So from this, you cannot kind of get any kind of commercial gain. So that's sort of the breakdown of the different ways that these can be licensed. Again, it really helps if they're depositing this in a platform that allows for sort of to choose a license from a menu, but sometimes that's not possible. So you can find the information from all of these sites. They're linked here in the slides, but they often will give you free text that you can use to use in your metadata. So just to kind of talk about this detailed provenance and kind of questions to ask. So if you are working with someone or you're working on a project yourself, sort of things to think about as you're going through and you're preparing to share your data. And of course, kind of as Nathaniel would say, I said earlier, that these are all things to start thinking about at the beginning of a research project, but we know that that's not always possible. So, so looking at sort of the data lineage, what was the data source and what transformations were performed. And you can also have that embedded XML provenance information included in your shape files. And I'll kind of reiterate, shapefiles are the most persistent geospatial vector format thus far. So transforming a feature layer from a geodatabase to a shapefile may be a good idea if you're working with that. But however, they are ubiquitous and many softwares can open them. And shapefiles are still technically proprietary. And they're made of several files that depend upon each other. So they must be packaged together. And so you're sort of looking at all of the different types of information used in this and making sure that that's all packaged together. What kind of softwares, models, or scripts were used. So if you're working with any software, any tables that were used in the software should be downloaded as CSV. If you're using models and Python scripts, models within ArcGIS can be saved as Arc toolboxes, which converts the model into a Python script. For purposes of data curation, it's recommended that the original model be kept along with exports of the models to both the Python script and an image capture in order to understand how the model was built and the relationship created among the various geospatial layers and processes. This sort of embedded XML, making sure that that's machine readable, provenance information, the original source, any derivatives, and looking at all of those associated files, any tabular or vector files that were connected with that. And are all of the coordinates included in the tables, which is again, going back to that accessible piece was, there's not always guaranteed when you are working with shape files. So, so these are just some ways to think about this and questions that one could ask themselves or ask someone that they're working with who would like to make their data fair and especially reusable. So making sure that all of these sort of elements are in place and really what, I think all of the other sort of elements of FAIR lead up to this. So you really want to make sure that that once everybody gets to it, they can access it, that it's interoperable, that they have that they can actually use it. And so there's just a couple of these sort of barriers to that one could kind of talk about and think through. And I think this is sort of a way to wrap this up for us, is to just sort of think about FAIR as a spectrum. So not that, we kind of looking at progress, not perfection here in terms of what everyone is capable of. It takes a lot of extra attention, extra energy to make sure that the data are fair. But there are places to start. So at the top here, my geospatial data are structured and organized within a geodatabase that uses a naming convention. That's a great place to start for FAIR. I've updated project level README file that includes a file inventory. Also great. What we've talked about thus far are really kind of like benchmarks, like that's the goal, but all of those are excellent things to have. I've used controlled vocabulary for variables in my metadata, so standards. I have metadata in an XML or GML file that aligns with the widely used standard. I share the data provenance and chain of custody for data. I license my data. And I publish my data as a web service in a repository which uses GeoBlacklight as a discovery layer. So GeoBlacklight is that metadata standard that we talked a little about earlier, but it's also a discovery platform that really allows people to view geospatial files and to describe them in a really more layer, all of the layers, all of the different elements of the metadata are available and interoperable. So so this is really kind of, that would be the the best, because you essentially have to have everything leading up to this in order to put this in a repository with that discovery layer. So so again, it's a spectrum. It's not always perfect, but I think it's essentially sort of a journey of making sure that you're trying to at least apply some element of the FAIR principles in the work. So so at this point, we'd like to take any questions from the group.
Any questions?
I have a question.
Yes.
Hi, it's Courtney from TDL. I'm wondering, John, I was really intrigued. I liked your slide on the GitHub question. How often do you think you get that? I'm wondering, Nathaniel, if you get that as well.
Yeah, I'll just say that, I mean, it's not even necessarily in consultations, but if you just have friends who are working in research, you know, they're using GitHub. That's my experience, that it's pretty common, and this the standard in many fields. I don't know, Nathaniel, what about you?
I rarely get those questions. Usually I just refer them to the digital collections person. So they help them. And then we've been trying to encourage people to use Dataverse. So I've not had a lot of issues regarding that, but it's something that once a while comes up.
Thanks for that, y'all.
Yeah. I was just having lunch before this with somebody who was talking about their geospatial data, and I was telling them about my webcast. They're like, "Oh, we just put everything in GitHub." I was like, "Well, I actually have a slide about that." It's great. I mean, I think it's a great resource too, but they're different.
There's a question from Anna. It says, where can I find the levels of metadata to include? And for example, what might be minimum, added value, extensive? You want to take a shot, John?
Sure. So I would say I would probably go back, Anna, great question, and look at some of the standards. One other, I think, great resource for this is it just really, and again, like metadata completeness is really kind of up to the standard of the repository. It's often the researcher, the research community, but there are several standards that you can look at. I mentioned a few earlier, but maybe looking at one other great place to look for this, that, hang on one second, that I think I may have right here, is there's data primers from the Data Curation Network. And these actually, Jessica and I worked on one for GeoTips last year, and they have several. So these are primers basically for a curator on what to do with the different file formats. So this one is on geodatabases, GeoJSON, GeoTIFF. And so that can give you kind of a different, your different options for the levels of granularity for your layers, and what you would need to make sure that you were making visible.
Yeah, and also the federal government has some standards, but those are used usually for the XML file that comes with the shape file. So you could look at that and then include a whole bunch of them. I've shared a link, the FGDC Gov metadata, / metadata. So you can revisit that and take a look at some of the things the federal government requires. Yeah, a lot of them, there are a lot of different parameters, but if you provide as much as possible, that's great. So, yeah.
And I see the coordinates put the metadata dictionary in for the TDR in there too, and that's really helpful. And a researcher can choose geospatial data metadata to be included in their record, and that can be that will prompt them to answer a lot of the questions in a certain level of granularity. Great question.
Mm-hmm.
I know we're at the hour, so I really want to respect everyone's time, and I want to thank you all so much for coming. And I know that I didn't have quite the je ne sais quoi that our colleague Jessica Trelogan would have had to share a lot of the data, but thank you so much. This was a real pleasure. And Nathaniel, did you have anything else you wanted to say to close us out?
All that I would just say is, let's keep creating metadata whenever it's possible. So
Yay.
yeah, we'll turn over to Alex. Alex, you have anything else to say?
Not on my end, but that was really fantastic, everybody. Thank you so much for presenting.
Great, thank you. And we'll make these slides available.
Yes, and the recording as well.
Fantastic. All right, thank you so much, everyone.
All right,
Have a
thanks,
great
everybody.
rest of your day.
Sure.
Bye, y'all.
Thanks
Thank
so
you.
much.
Great job.